Okay, guys, so I'm actually going to be talking to you guys about the very last type of classification of reactions that we need to predict products for, and it's neutralization reactions, which really I think you're going to find is fairly simple. It's just a special type of double replacement. Ms. Marcus has already done some demonstrations that showed you neutralization reactions. Later on in this course, we spent an entire unit talking about acids and bases. And so we'll come back and we'll revisit this. So I thought it'd be easiest, honestly, to just fill it in your notes as we go, kind of like I did with the last couple. So if you give me just a second, I'm going to get to presenting and then we will end up looking at our notes. So I'm wanting you to get to page 14 in your notes. So page 14 in your guided notes. And I forgot that I had that facing that way. Okay, so this is where we're at. Oh, I got some definite sunlight. We're finally getting some sunshine in Texas. Got some sunlight that's impacting how you guys are seeing this right now, but I think we can make it work. Okay, so neutralization reactions, there's probably different ways that we're going to see a definition for it, but they all are going to have the same underlying theme to it. Basic idea is when an acid and a base react to form a salt. Remember, chemists call things besides just sodium chloride a salt. So to form a salt, any ionic compound and water. So we'll always get that as our end game. Okay, so the general formula for this would be H. We know that it's a hydrogen, and I'm just going to write like HA. I don't know what that other anion is going to be. And it's going to combine with, I'm just going to call this a B. I don't really know. This can be any cation. And likewise, that would have been any anion. But it has to have, and I'm going to, go ahead and put parentheses around it. It has to be combined with a hydroxide. And we're going to end up with water. Now, you're going to see me write water kind of funny because I've learned, for me at least, it makes it easier to balance. I know we normally write water like this, H2O, but I'm going to write it like this. I'm going to write it as HOH because it makes it kind of easy when I'm looking to see how to balance it. Oh, the clouds came in. It makes it easier to see now. So, I'm getting the H from here and the OH from here. And then we form our ionic compound. Now, just because we always write the cation first, I'm going to write the B in front, and that's representing the anion, so I'll write the A behind it. So that's a general formula. Okay, so this is an example of one. Now, again, here is your hydroxide, and this is why I like to write it as what's happening here. We have HOH, and, +1 for hydrogen, hydroxides are -1. It's already balanced. And then we end up with NaCl. Again, those are +1, -1. So this is one where there just is not any balancing issues. Now, by definition, acids are always aqueous. They have to be. And we just, most of the time, our bases are aqueous as well. But just by definition, your acids have to be. That's just a little bit of extra info. Now this one's already balanced. Next one will probably highlight why I like so much to write it as HOH. So again, look up where we're getting this from. H +1, OH -1, it's already balanced. If I write it H2O, it gets kind of funny when I try to go back and look at the equation. This lets me see everything really quickly with how to balance. And then my ionic compound is Li, and we need 2 of those because sulfate is a -2 charge. So it's not balanced yet, right? Here's what I mean by, if I write it like this, I can keep those polyatomics kind of the same across the board. We have hydrogens, we have sulfates, we have lithiums, and I have OHs, and I can really continue to see it on both sides of the equation as long as I write water kind of funny. So I have 2 hydrogens here, 1 sulfate, 1 lithium, 1 hydroxide. Over here right now I have 1, 1, 2, and then 1. So we got an issue with our lithiums are off balance. It doesn't matter what you pick first, but why not pick that one? So whenever I do that, I end up with 2 lithiums and 2 hydroxides. So then I can come over here and go, okay, well, how could I fix that? Put a 2 right here. And like I said, it just makes it really easy to see what's going on. Changes this to a 2, changes this to a 2, and I'm done. All right, it's balanced. So that's really good, you guys. Neutralization. So it's things that we've already have learned with double replacement. It's just a very special type of double replacement. So special that it gets its own unit when we learn more about acids and bases. That'll be in second semester, hopefully when we're all together every single day of the week. Hope you guys are doing well. We will be talking soon.